We are in the Laboratoire de Conservation Restauration in Avenches, Switzerland. Avenches is an archaeological site with lots of archaeological diggings. And we have regularly metal finds coming in this lab, which have to be conserved and restored. Among these metal finds, we observe copper alloy objects with important flaking and cracking. We'd like to study this phenomenon. So here is the ring. You can see the cracking.
Yes.
We have also flaking. Here
Nice.
we have a big lacuna.
Mm-hmm. The metal, you can
Yes.
see.
Yeah.
And the whole stratigraphy. You have another picture with better stratigraphy?
Yes.
Oh, very good. Yes, these cracks which are going through the whole thickness.
Exactly. Sometimes you have also a gap between the second corrosion layer and the metal with the first corrosion layer,
Okay.
but sometimes it's quite adherent.
So that is what you try to represent with this drawing.
Yes.
It's quite complicated stratigraphy, and this might be quite representative of what we have on the whole object, cracking going through the whole structure. The system is not able to study this stratigraphy that we made by drawing. So we have now to transform this stratigraphy in a digital representation.
Okay.
So here we start building the structure. We have the metal, you have seen, and the first corrosion layer. There will be more. So now you are starting building it. You have now to inform each stratum with what you have seen under the binocular. So the color, whether it's hard, whether it's cracked. So for the color, it's visible. You see the color, but sometimes it's not visible. So you will have to fill all the information related to each stratum, and then you will build slowly the whole structure you have seen. But you understand that it's an abstract way of representation, and that the tool can read. Okay, so now you have managed to build your whole stratigraphy. So again, it has to be relevant to what you observed with your binocular microscope, but it seems to be. The system can read that, but you have to question the database. It could be that in the database we have an object which has exactly the same stratigraphy. So for that you have to click on Find Similar. What you see here is that the screen is divided in two parts. On the right, you compare your stratigraphy with stratigraphies of objects from the database. So your object is there.
Okay.
And then you have the material of the database which is closer to your object. These stratigraphies have been taken by binocular, which is normal, but you have some others which have been observed in cross-section.
Okay.
On the left, you have the parameters that you have filled before for each stratum, and you see that they have different level of importance, but that has been defined by ourselves. As professionals, we consider that these parameters are characteristic of what we would expect when we observe a structure on the binocular. So next, what you have to do is to click on the objects to see whether they have indeed the same problem as yours. So
Indeed.
that is, but that is coming from Bern. It's not in your institution.
No.
So it means that in the canton of Bern, you have a similar problem that yours. So that is interesting, but you can check whether in the list of the proposals you have some other similar objects. next would be this one. That one is coming from Lateneum, so not far from here, but it's a lake patina.
It's quite different, yes.
So it's different. You don't have the flaking phenomenon, so it's not a good proposal. So let's see the next one. That is an axe, but it's not coming from Switzerland. It's from Lons-le-Saunier, so it's on the other side of the border, still in the same region, but you have again the flaking phenomenon. So now the next step would be, since the system is proposing you objects which are not similar to yours, to make it more relevant. So you have to come back to the values which are given to you, okay, and perhaps change the values. You can do it, and we will change the cracking because the cracking is observed on your problematic object. So we highlight specifically this parameter, and you have to retry again to see whether we will have a better match. So you see now that we have a better matching because we have first the pin, then the axe, and we'll have to check with the chisel, but it could be that the chisel is a good candidate too. Okay, you see flaking again.
Yeah.
So now you have a selection of objects from the database telling you that there is a good chance that this phenomenon is already known in the database. So let's have a look at one of them, for instance the axe. In the case of the axe, a sample could be taken. You didn't take any sample, you could not on the object, but here they could. So if you go down, you see that a sample has been taken, so we'll have a look at the sample. Same stratigraphy as yours, we go down again. So here you have an idea of the stratigraphy, you have the cracks here that you observed, but it seems that it doesn't go to the metal surface. Here you have the conclusion, and it says that you have stratigraphy, but even if the phenomenon is well described, there is no reason why, in fact, this alteration developed.
Okay, now I've seen that we are not alone with this problem. There are other institutions with objects that show this kind of flaking or cracking. We observed it immediately after the digging, after the object was brought in the lab. So, but I see that other institutions have encountered this problem in the while the storage of the objects. I can't see yet a reason why it happens. So I hope that if this database will be enriched with other cases, we once can solve the problem and now discover what is the reason for this kind of degradation of the objects.